Hi everyone, today I'm going to present my study titled A Simple Multivariate Time Series Analysis Examining the Effect of Technological Advancement, Cross-Fixed Capital Formation and Renewable Energy on Malaysia's Decarbonization. Okay, introduction. Malaysia as a developing nation is committed towards its social and economic development obligations to provide a better standard of living for its citizens. Thus, economic activities plays a key role in terms of achieving its goal as a high-income country and to ensure quality of life of its people. The United Nations Framework Convention on Climate Change has adopted a concept of common but differentiated responsibility in year 1994. Right, the concept stated that developing countries are allowed to have high growth but expected to take responsibility to mitigate their climate change specifically. Right, in other words, or in simple words, developing countries are allowed to have a high income, right, to generate more economic activities, but at the same time, they need to control the environmental issues. Right, if we observe the Malaysia's carbon emission, right, from the period 1975 to 2017, you can see that it shows an intense upward trend, or the rapid, or simply shows an increase, a rapid increase in the emission or carbon emission in Malaysia, right? So the issue here is why we fail to control this rapid increase in carbon emission, right? So the need to understand what are the factors contributing to this increase in carbon emission is essential in terms of if we need to put effort to mitigate the problem drastically and seriously in order to shift towards a low carbon development path. Now, the core objective of this research is therefore to determine the key macroeconomic factors, focus on Malaysia's carbon emission, and definitely these factors will able to provide insights to pursue a sustainable economic growth and importantly to decrease carbon emission or to help to enhance decarbonization. Right, literature review. Right, there are two scientists that have addressed the environmental problems known as the IPAD model in the year 1971. Right, the two scientists are Paul Ehrlich and John Holdren. Right, in his model, right, as described by Molinas in 2010, I here stands for pollutant emission, P is population, A is GDP, and T is technology. And Molinas explained further that technology also signifies the intensity of its impact on economic growth. Right, the study of the relationship between GDP and environmental pollution also discussed by Professor Kuznets in his much related study to the validity of the hypothesis. Right, this hypothesis is known as the environmental Kuznets curve. Right, what the hypothesis hypothesized here is the pattern of EKC, which is an inverted U shape, which describes a very low income country, they will pollute less, but when their GDP or when their GDP increases, the pollutant emission will also increase. However, when the increase in income is sufficiently high, this is talking about the experience of advanced nation, right? And they will meet or reach a turning point. And at this point, Mailer in year 2001 observed that the level of pollution begins to decrease as income increases further. Right, it is undeniable that the usage of new technologies can cause production of goods to become more efficient and to be cheaper contributes to the economy and social being of a nation, as well as can result in a country's exports to be competitive globally. So in other words, when your goods are cheaper, it means foreign nations will buy your products, and definitely it will contribute to the economy and social being of a nation. This is what Kaliskan found in the year 2015. Right, a study by Dooley and Yen in year 2019, right, found that a single threshold effect regarding income level, whereby green technology innovations only impact those high income economies, of which an inverted U-shaped relationship between per capita emissions and carbon emission and per capita GDP was found. Right, so the inverted U-shape can be seen, right, in these nations or in the advanced countries, right, because they are the one that are able to innovate new technology or green technology, right, that help to reduce the emission. Right, another variable that is of importance is energy, because energy plays a role in terms of generating the economy, right? But at this time, because of the global warming issue, we can see that now nations are more focused on renewable energy to reduce their dependency on fossil fuel type of energy to generate their electricity, right? So study by Lau et al. In year 2018 found that in Malaysia, economic growth and FDI are the crucial initiators for renewable electricity consumption. But in the long term, foreign trade revealed, right, a negative impact on renewable electricity consumption, whereas CO2 emission has no significant effect on renewable electricity consumption. Right, much a different study is looking at a survey, right, conducted by Sena et al. In year 2021, this year, examining the factors influencing the electricity consumption among Malaysian households, and they look at technology perspective, building and appliance, and also socio-economic perspective. What they found that appliance characteristics factors such as air conditions, fluorescent lamps, and flat screen TVs were the main variables that influenced electricity consumption, and that occupant behavior factors had a more significant impact than socio-economic factors. Right, data and methodology. We run a simple multiple regression analysis, right, on Malaysia for the period 1975 to 2017, and we use 9 independent variables or 9 explanatory variables, which we have identified in terms of theory that show to have a causal relationship with carbon emission. So these are the 9 independent variables or explanatory variables. We have GDP, FTL, fixed telephone line, GFCF, gross fixed capital formation, electricity consumption, renewable energy, non-renewable energy, transport, foreign direct investment, and manufacturing, right? So when we run multiple regression analysis, we log the particular explanatory variables, we log the data, and we include the epsilon t, the error term, and we predict or we hypothesize that beta 1 here, beta 4 electricity consumption, beta 5 renewable energy, beta 7 transport, beta 8 FDI, and beta 9 MFC to have a positive coefficient, which is more than 0, whereas beta 2 FTL, beta 3 GFCF, and beta 6 NRWE to have a negative coefficient that is less than 0. Right, we also run a diagnostic check, right, to validate that the estimation meets the requirement of the classical linear regression assumption. All right, there are 7 assumptions, right? So these 7 assumptions, definitely number 1 is based on the model. We've met that assumption. Number 2, error term, this is the denotation, has a 0 population. 3, all explanatory variables are uncorrelated with the error term. So this is referring to the error term or the epsilon t, right? And then we see that the error term is uncorrelated, means no zero correlation. The error term has a constant variance, means no heteroscedasticity, no perfect multi-connectivity among each explanatory variable. And finally, the error term is normally distributed, drawn independently from a distribution with a mean of 0 and a constant variance. So these are all the denotations of each assumption. Right. Sources of data we collect from World Bank and Organization for Economic Cooperation and Development, which gathered by the World Development Indicator or WDI. Right. For technology or technological advancement, we use a proxy, which is telephone fixed line subscriptions. And this is a common proxy for developing countries, because data on R&D are not sufficient or not enough to cover this period. So if we use R&D, we will have issues on missing data. Right, results. So look at the preliminary analysis. The descriptive analysis, we look at the data mean score, the standard deviation, right? And definitely most important is to look at the normality of data. And here the W-test statistics show that we rejected the null hypothesis, all right, and data is not normally distributed. However, Lumley in year 2002 suggests regression analysis can be performed sufficiently with non-normal predictor variables with a moderately large sample size. So in our case, we have 9 independent variables plus 1 dependent variable. So we have 10 variables and we study for 43 years. So the sample size is quite large here, right? The observation is around 430 observations there. Right, correlation matrix. Correlation matrix actually is looking at the association among the variables. Right, for example, if you look at GDP and CO2 here, you can see that the correlation matrix shown a value of 0.99. What it indicates is that there is a strong correlation or association between CO2 and GDP. Right, actually this is the indicator of what we see in terms of multi-connectivity problem, because of their strong relationship, strong association between the two. Some are positive, some are negative, right? So most importantly, this correlation matrix is actually only showing the strength of the association. It does not show any impact or effect factor here. Right. This is our key analysis, the multiple regression analysis, right, for all the variables. So what we can see, the adjusted R squared, okay, is given the value of 0.997. So this indicates that 99.7% of variation in the outcome variable is explained by the explanatory variables, and this particular regression is acceptable because the statistic is significant at 5% level of significance. There are 4 explanatory variables that show significant relationship, which are GDP, MFC, GFCF, and REW, right? Renewable energy, right? The difference is that 2 of the variables, GDP and MFC, is showing a positive relationship, whereas GFCF and REW are showing a negative effect on carbon emission. So what we can interpret here is that when there is an increase in GDP by 1 percentage point, it will cause the CO2 emission to increase by this beta coefficient, 0.865 percentage points. Same goes to MFC. It will cause 0.399 percentage points increase in the carbon emission if we increase the MFC by 1 percentage point. Okay, so it's what we can see that the GDP here contributes much higher because the value of the beta is 0.865 as compared to MFC. Right, for GFCF, right, and renewable energy, you can see that they have a negative relationship. So what it means is that an increase in 1%, an increase of 1 percentage point in GFCF would result to with a decrease in carbon emission by 0.198 percentage point. So same goes to renewable energy. If you increase the renewable energy by 1 percentage point, it will reduce carbon emission by 0.294 percentage point. Right, diagnostic checks, as we mentioned earlier, we need to test the assumptions. So the first assumption that we test will be the fourth assumption, which is no serial correlation, and we have to conduct autocorrelation tests, and there are two statistics. One is Durbin-Watson statistic, and the other one is Bush-Goffrey LM test. Right. So if you look at Durbin-Watson, D statistic, it showed the value of 1.9. Right. The rule of thumb is that for Durbin-Watson statistic, the range of 1.5 to 2.5 means that is considered normal for time series. However, if the value is 2, it means that there is no autocorrelation. Since the value of our Durbin-Watson is 1.9, it does not show the no autocorrelation. We conduct another statistical test, that is BGLM test, and we found that the p-value here, the chi-square, is insignificant, meaning fail to reject H0, and it proves that there is no serial correlation. Right, the next one, heteroscedasticity test. All right, this is to confirm that the error terms do not have constant variance. We are referring to assumption 5. And definitely the common statistical test, we use Bruce-Pagan or the Cook-Weisbach test, and we found that it rejected the null hypothesis, and it implies the error terms do not have constant variance. And the final diagnostic checks is the multicollinearity regarding assumption 6, and we look at the variance inflationary test, and we can see that the VIF for all nearly all variables except for 2 is exceeded 10. So it shows that the explanatory variable is highly collinear with other explanatory variables, and definitely it means there exists multi-collinearity problem. However, this does not mean the regression equation is unacceptable, right? Because for prediction purpose, multi-collinearity is not an issue here, right? And the regression coefficient will be sensitive to specifications and can change considerably when variables are added or dropped. So in this study, we choose 9 explanatory variables, and they are chosen based on their theory, right? So it should not be any issues in terms of running the regression here regarding a multi-collinearity problem. Right, conclusion, right? What we found is that the results discovered 2 strong positive significant link between GDP and CO2 emission and manufacturing output with CO2 emission. So it means that the higher the GDP and the higher the output from manufacturing sector, the higher will be carbon emission. Right, and we also found that 2 other variables, which are GFCF and renewable energy, show a negative relationship with CO2 emission, and it implies that when government invests more on increasing their GFCF or gross fixed capital formation and invest more on renewable energy, it will have to lower the emission. That is the reason why now we are moving towards the usage of solar, hydro, and biomass energy in order to cut our emission. But in Malaysia, most of the renewable energy, we say 93% of the renewable energy is using hydropower, right? So this was in year 2018. Right, what the results suggest is that Malaysia, to encourage and emphasize to use the usage of renewable energy in generating its economic activities, right? Besides that, you need to use, government needs to spend on upscaling the gross fixed capital formation, such as, you know, setting up plant, purchasing equipment, machinery, and improve infrastructure in power sector, which can able to control carbon emission. So these findings will further emphasize that the Malaysian policymakers need to develop a strategic plan and tools to manage carbon emissions in order to attain the two SDGs, that is SDG 13, climate action, and SDG 8, at the same time, for the people to get decent work and economy to achieve economic growth, right? And as stated in the United Nations Sustainable Growth Goals. So with that, I end my presentation. Thank you.